Welcome to Tapasya YouTube channel. Okay, previous class we are completed about concave mirror and convex mirror. Okay, as you know earlier, concave mirror. In concave mirror, all the rays are converge. All the rays are converge. That is concave mirror. Yes, all the rays are diverge. Okay, that is convex. Convex mirror. All the rays are converge, that is concave mirror. Yes, how concave mirror it is, okay, which is like concave is you are seeing is what cave, okay, that's why that is what concave mirror. It is a concave mirror. In the concave mirror, all the rays, the normal lines are converge. Yes, in the convex mirror, see, it is concave portion. This is the portion is concave. Okay, this is the portion is what convex. Yes, in the convex, yes, where the lines are present here. Okay, it is what convex mirror. Okay, where from we are getting concave and convex. This concave and convex we are getting from sphere of the mirror. From the sphere of the mirror, little portion, some portion we are getting. Okay, this is the portion. Okay, this portion if we are getting, okay, that acts as what? Concave mirror. If you take any piece, this is also acts as one of the concave mirror. Now, where there are cave is there, okay, that is concave. Okay, the outer portion, okay, this we can call as convex mirror. Concave and convex mirror, okay, these are coming from the sphere. Okay, now some of the terminologies in spherical mirror, okay, that we are going to learn now. Okay, what are the terminologies? Okay, first terminology is pole. Okay, what is pole? Okay, it is concave mirror. Now, the midpoint, this mirror midpoint is what? Here midpoint is there. Okay, that we can call as P. Okay, simply I have to say the midpoint of the mirror is called pole. The midpoint of the mirror is called as pole. Okay, next is center of curvature. Next point is what? Center of curvature. How to find center of curvature? Now take a concave mirror. It is a concave mirror. Now, where from we are getting it? Okay, from the sphere, which we are getting from the sphere. If you imagine it is complete sphere, imagine. Yes, where will be the midpoint center of spherical mirror? Center of the spherical mirror. Okay, this point you can call as C. Yes, from this any line. Okay, this is a normal line. This is also what? Normal line. Okay, the line joined to the mirror. Okay, where there are two normal lines are met, you can call center of curvature. Yes, we can write center of curvature. The normal line or met one point. That point you can call as the point is called as the center of curvature. Center of curvature. Okay, this is about center of curvature. Okay, all the normal lines are met one place. That place we are calling as center of curvature. Okay, we have completed pole and we have completed center of curvature. Okay, next terminology we can use in spherical mirror. Okay, that is principal axis. What it is? Principal axis. Principal axis. Principal axis. Yes, how to find principal axis? Okay, as you know earlier, okay, it is a concave mirror. Okay, already you know this point you can call as what? Pole. Okay, the line which is passing through the pole, the line which is passing through the pole, that we can call as principal axis. Okay, note down, the line passing through a pole is called principal axis. Okay, this is about principal axis. Now, next terminology we can learn, that is radius of curvature. Radius of curvature. Yes, how to find radius of curvature? Now, it is concave mirror. As you know, it is P, midpoint pole. Yes, from the pole, one of the line which is passing, that you are calling already principal axis. Now, what you want to find? Radius of curvature. Now, the line, the normal line, where the normal line is met, what you can represent that? Center of curvature. Now come to the point. The radius of curvature, the distance between pole to center of curvature, that you can call as radius of curvature. Now I am writing here the distance between from the pole to center of curvature is called radius of curvature. Radius of curvature. Okay, radius of curvature we can represent with the letter capital R. Okay, center of curvature we are representing letter capital C. Yes, we are representing pole capital P. Okay, till now we are completed. Okay, some terminologies. Okay, next terminology is focus. Okay, before going to know about the focus, we have to know about what is incident ray, what is reflected ray of concave mirror. Now, first we have to know about what is incident ray, what is reflected ray of concave mirror. Now, as you know earlier, it is a concave mirror. Yes, you know it is what? Pole. Already you know it is pole. Is from the pole, one of the line which is moving, that you are calling as principal axis. Now, any ray which is coming from certain distance of the object, okay, this ray you can call as incident ray. Incident ray. Okay, it is incident ray. after met mirror, which is getting what? Reflection. Okay, that's why this ray you can call as reflected ray. You can call reflected ray. Now here, incident ray, reflected ray, middle I am drawing one of the dot line. Okay, that dot line shows center of curvature. That dot line shows what? Center of curvature. Now the angle between normal to incident, that is angle of incident. Angle of incident. Now angle between normal line to reflected ray, that you can call as angle of reflection. Angle of reflection. Okay, this is about incident ray, reflected ray, and normal line. Yes, the angle made to the incident ray, that is angle of incident, the angle made by the normal to the reflected ray, that we can call as angle of reflection. Yes, as you know earlier, the first law of reflection, okay, angle of incident is equal to angle of reflection. I is equal to R. Okay, this is the first law of reflection. Now we have to know about focus. Yes, before this we could not understand focus very well. Okay, now we can understand very well what is focus. Now, to understand the focus, I am drawing here concave mirror. It is a concave mirror. As you know, I am drawing the line from the midpoint. Tell me what it is. Pole. It is pole. From the pole, one line is moved. Okay, that you can call as what? Principal axis. Yes, the midpoint of the sphere, what we could represent it is center of curvature. Now, some of the rays which is coming from the sun from the certain distance. Okay, imagine it is one of the ray which is coming from certain distance. Okay, after met this mirror, what is getting reflected? Suppose one more ray which is coming from the certain distance. Yes, where it will goes? It will comes to here. Now here one more ray, incident ray, where it will meet? Here it is meeting. Okay, next ray, it is incident ray, where it meets here. Now you look at here, the ray which is coming from certain distance, okay, that is what? Incident ray. It is also incident ray. Okay, down it is incident ray. This is also what? Incident ray. After met the mirror, yes, here we are getting reflected ray. After met the mirror, okay, this arrow mark shows to us reflected ray. Incident ray after met the mirror, which is getting what? Reflected. Where there are all the reflected rays are met, that place you are calling as focus. I am writing here definition. All the reflected rays met one place, that place is called focus. What you are calling it as? Focus. Okay, this is definition of focus. Yes, one more terminology we have to know after focus: focal. Okay, next terminology is focal length. Focal length. Okay, what is focal length? How to represent it? Now, as you know earlier, tell me it is what? Concave mirror. it is concave mirror. Now the midpoint of the mirror is called as pole. From the pole, one is line that you passing, that you are calling as principal axis. Now the midpoint of sphere, where it is here, midpoint of the sphere you can call as what? Center of curvature. If any ray which is coming from certain distance, the ray which is coming from certain distance, that you are calling as what? Incident ray. Okay, where it is getting reflection like this. Okay, one more ray which is coming, incident ray, you see arrow mark you observe. Yes, where it is met, which is met one place. Okay, two reflected rays are met one place, what you are calling earlier, that is focus. Okay, where there are two reflected rays are met, that place we are calling as what? Focus. Now our topic is focal length. Focal length means the distance between from pole to focus. The distance between pole to focus is called focal length. Focal length. Okay, this is the definition of focal length. Okay, what is the relation between radius of curvature and small f? Okay, this is the small f. Focal length you have to represent with small f. Focus you have to represent with capital F. Okay, what is the relation between radius of curvature means R? Radius of curvature. Radius of curvature means what? R. R to small f. What is the relation between capital R to small f? As you know earlier, okay, the distance between from where to where, P to C, we are calling as capital R. The distance between P to F you can call as small f. How many times greater? R. Okay, R is 2 times R greater. Okay, that's why R equal to, you can write 2f. Okay, that is relation have between capital F and capital R and small. Now reflection takes place in convex mirror. Okay, till now we are completed concave mirror, all the rays are converge. Yes, in convex, rays are diverge. Imagine, okay, this is one of the now we cannot say it is whether it is concave or convex. Yes, arrow mark shows, this shows, or the dotted line shows. Okay, now you can say it is what? One of the convex mirror. Now, as you know earlier, how you find in concave mirror, same as you have to find the midpoint of the mirror, you are calling as pole. Okay, the line which is passing through the pole, okay, that you can call as principal axis. Okay, the midpoint of the sphere you are calling as what? Center of curvature, as you know earlier, or in the concave mirror, same as. Now the ray which is coming from certain distance, it is incident ray. After met the mirror, what it converge or diverge? In convex mirror, always it is going to be what? Diverge. You see, it is getting what? Diverge. Now one more ray, it is incident ray. Now it is getting what? Reflected. Okay, converge or diverge? Diverge. Yes, you can draw one more line. Okay, it is incident ray. After met this, it is getting what? Reflection. Okay, draw one more ray here. After met the mirror, incident ray. After getting the mirror, which is getting what? Diverge. Okay, all the rays are diverge. How image is forms? Okay, image is forms when you have to extend all reflected rays. Okay, it is incident ray. it is reflected ray. Reflected ray you have to extend. Okay, this is one more reflected ray, this is one more reflected ray, this is one more reflected ray. All the reflected rays are met one place, that you are calling as focus. All reflected rays are met one place, focus, as we recognized in the concave also. Next, okay, where center of curvature we can find, you can draw the dot lines between incident ray and reflected ray. It is incident ray, it is reflected ray. From incident ray to reflected ray, draw one line. Now this is incident, this is reflected. Yes, between you have to draw one line. Yes, here also draw one more line. Yes, here draw one more line. All the lines are joined. Okay, that place we can call as what? Center of curvature. That what we can call center of curvature. Okay, it is a pole, this is a principal axis, this is a center of curvature, this is focus. Now the distance between P to C, that is what? Radius of curvature. The distance between P to F, that is small f, focal length. Okay, these are the terminology we can use in convex mirror. Convex mirror. Okay, this is the terminology we can use in the convex mirror. The convex mirror, where we are getting from the sphere. The piece which is reflected from the sphere, okay, that is the piece. Okay, that piece we can call as convex mirror. In the convex mirror, all rays are diverge. Okay, these are the terminology we can use in the concave and convex mirror. Okay, next class we will learn about ray diagrams.